Imagine standing on an ancient floodplain 150 million years ago, surrounded by towering conifers, ferns the size of cars, and the distant rumble of a massive herbivore making its way through the undergrowth. A moment later, it emerges from the trees, a creature unlike anything alive today. Its back is lined with enormous upright plates that sway gently as it walks, and its tail ends in four long, wicked spikes capable of delivering a lethal strike. This is Stegosaurus, one of the most iconic dinosaurs in the history of paleontology, a symbol of prehistoric power and mystery. Stegosaurus roamed the Earth during the late Jurassic period, approximately 155 to 150 million years ago, inhabiting what is now the western United States. Fossils have been discovered in Colorado, Utah, and Wyoming, particularly within the famous Morrison Formation, a treasure trove of Jurassic life. The landscape back then was vastly different, semi-arid, with wet and dry seasons, dotted with river channels, open woodlands, and lush fern prairies. These environments supported an extraordinary cast of dinosaurs, but Stegosaurus stood out instantly. One of the first things you notice about this dinosaur is its distinctive double row of large plates that run along its back from neck to tail. These plates, called osteoderms, could reach over 60 centimeters, 2 feet, in height, and no two plates were exactly alike. Their shape resembles a row of giant stone leaves or shark fins. For decades, scientists have debated their purpose. Were they defensive shields, temperature-regulating structures, or vivid display features used to communicate with other dinosaurs? Today, the leading hypothesis suggests a combination of thermal regulation and visual display, thanks to the plate's internal network of blood vessels. Imagine these plates flushing with color, perhaps deep red during displays, making the Stegosaurus appear even more formidable or attractive. Despite its powerful appearance, Stegosaurus was an herbivore, feeding on low-lying plants. Its mouth was equipped with a small, beak-like structure for cropping vegetation, and its teeth were surprisingly tiny and leaf-shaped, designed to handle soft foliage rather than chewing tough woody material. Scientists believe Stegosaurus consumed ferns, cycads, horsetails, mosses, and early conifer shoots. Because it lacked sophisticated chewing mechanisms, much of its digestion likely occurred through fermentation in a large gut, much like modern herbivores such as cows or elephants. Physically, Stegosaurus was a massive creature. The largest species, Stegosaurus armatus, could reach 9 meters, 30 feet, in length and weigh up to 5 tons. Its body was low to the ground, supported by powerful hind legs and shorter front limbs. This gave the dinosaur a distinctive sloping posture, with its hips significantly higher than its shoulders. Its small head, astonishingly small for its body size, was positioned close to the ground, giving it constant access to vegetation while minimizing energy expenditure. But perhaps the most infamous part of Stegosaurus anatomy is its tail weapon, the thagomizer. This arrangement of 4 long spikes, sometimes exceeding 1 meter, 3 feet, in length, was capable of delivering devastating blows. Evidence from fossilized tail vertebrae shows that Stegosaurus could swing its tail with remarkable agility, likely used to fend off predators such as Allosaurus and Ceratosaurus. In fact, paleontologists have discovered an Allosaurus fossil with a puncture wound the exact size and shape of a Stegosaurus tail spike, confirming these spikes were not just for show. They were deadly tools of survival. Interestingly, Stegosaurus also possessed one of the most disproportionate brain-to-body ratios of any dinosaur. Despite weighing several tons, its brain was roughly the size of a walnut. This doesn't mean Stegosaurus was unintelligent. Rather, it indicates that dinosaurs relied more on instinct and efficient body coordination than on advanced cognitive processing. Some early scientists even suggested the dinosaur had a second brain near its hip region, but modern research has debunked that theory. Socially, Stegosaurus behavior remains a mystery. Some fossil sites show multiple individuals found together, but it's unclear whether they lived in groups or simply died in the same area by coincidence. However, the presence of display-like plates suggests the species likely engaged in visual communication, whether for mating, intimidation, or establishing territory. As a symbol of prehistoric life, Stegosaurus continues to captivate the imaginations of scientists and the public alike. Its unusual anatomy, powerful defensive adaptations, and unique evolutionary story make it one of the most recognizable dinosaurs ever discovered. Whether standing proudly in museum halls or appearing in documentaries, Stegosaurus represents the incredible diversity and creativity of life that once dominated our planet. Stegosaurus continues to fascinate scientists and the public alike, not just for its unusual anatomy, but also for what it reveals about evolution and survival during the late Jurassic. This dinosaur belonged to the group Thyreophorans, or shield-bearers, which includes other heavily armored species like Ankylosaurs. Over millions of years, Stegosaurus developed its signature combination of backplates and tail spikes, a design that balanced passive defense, active protection, and visual signaling. Its body was a masterclass in evolutionary engineering, showing how form and function can work together to ensure survival in a predator-rich environment. The plates along its back are perhaps the most striking feature of Stegosaurus. Fossils show that the size, shape, and arrangement of plates could vary depending on species, age, and even sex. Juvenile Stegosaurus had smaller, flatter plates that became taller and more upright as they matured. Scientists believe these plates had multiple roles: thermoregulation, helping the dinosaur manage body heat; social communication, signaling dominance, territory, or readiness to mate; and intimidation, creating a more imposing silhouette to deter predators. Blood vessels inside the plates may have enabled color changes or heat exchange, making them dynamic tools rather than just passive structures. The thagomizer, or spiked tail, was an active defensive weapon. Unlike the plates, which mainly served as deterrents, the tail spikes could deliver lethal blows to predators. Biomechanical studies indicate that Stegosaurus could swing its tail with surprising speed and precision. Fossil evidence supports this. Paleontologists have discovered predator bones with puncture wounds matching the size and shape of Stegosaurus tail spikes, proving that the thagomizer was far from ornamental. This dual defense system, intimidating plates combined with a lethal tail, gave Stegosaurus an effective strategy against predators like Allosaurus and Ceratosaurus. Stegosaurus feeding adaptations were equally specialized. With a small, beak-like mouth and leaf-shaped teeth, it cropped low-lying plants such as ferns, cycads, horsetails, and conifer shoots. Without advanced chewing mechanisms, it relied on a large gut to ferment tough plant material, similar to modern herbivores like elephants or cows. Its low-slung body and hind legs taller than its front limbs allowed Stegosaurus to reach slightly higher vegetation while remaining stable and energy-efficient on the ground. This combination of posture and anatomy made it a highly effective herbivore in its environment. Evidence about social behavior is limited but intriguing. Some fossil sites contain multiple Stegosaurus individuals, suggesting they may have formed temporary groups. The plates likely played a role in visual communication within the species, whether to signal dominance, attract mates, or warn others of danger. Even with a walnut-sized brain, tiny compared to its massive body, Stegosaurus thrived, relying on instinct, sensory awareness, and its formidable defenses. Stegosaurus also provides a window into the late Jurassic ecosystem. It coexisted with massive sauropods like Apatosaurus and predators like Allosaurus, navigating floodplains, woodlands, and seasonal rivers. Its foraging behavior shaped plant communities, while its defenses influenced predator-prey interactions. The Morrison Formation, where most Stegosaurus fossils are found, preserves these rich and varied habitats, offering scientists a vivid glimpse into the ancient world. Culturally, Stegosaurus has left a lasting impact. Its instantly recognizable form, sloping back, armored plates, and spiked tail, has made it a mainstay in museums, documentaries, and popular media. Advanced studies, including CT scans of plates and biomechanical analysis of tails, continue to refine our understanding of this remarkable dinosaur. Stegosaurus remains an enduring symbol of prehistoric life, a testament to the creativity of evolution, and a reminder of the complexity and diversity of Earth's past ecosystems. In the end, Stegosaurus is more than a curiosity. It is an evolutionary marvel. Its armor, weaponry, feeding adaptations, and visual displays illustrate a creature perfectly suited to its world. Though extinct for millions of years, it continues to inspire wonder, curiosity, and appreciation for the power of natural design, leaving an indelible mark on both science and culture.